Hello friends, welcome back to my YouTube channel. And friends, have you ever thought that how Wi-Fi actually works? So in this video, we will discuss that how Wi-Fi works in our day-to-day life. So let's start very quickly. And in our last video, we talked about wireless technology and how Wi-Fi is one of the most common types. Please watch if you didn't yet. So please watch that video. I will put the video link in description and you can click on the I button to watch that video. So today we will deep dive into the Wi-Fi works. So let's start. The Wi-Fi is a technology that uses radio waves to connect your device to the internet through a wireless controller, router, or any central device which controls all the connectivity connected back to the ISP, taking the signals from the internet, connect your deliver to your end devices, and you are able to access the internet or other services. That is the Wi-Fi. Now we will discuss about the journey of internet data, the how it actually works. So how device work? The device use antenna to send receive signals. So it start with the internet service provider, which delivers internet to your home or modem. That modem is connected to the Wi-Fi router, which convert to the internet into the radio signal and broadcast them wirelessly. Means suppose that you have a internet connection with the ISP, then you have a router, then there's a switch, then there's an enterprise connection I'm talking about. But in home also it's internet that directly connected to your Wi-Fi router. Suppose here's a Wi-Fi router, then Wi-Fi router there's a fiber, or it can be the GPON or FTTH, any connection to till your home. Then your end devices or your mobile will connected over this Wi-Fi router and start accessing the internet. That is the journey of the internet of the Wi-Fi. So how device communicate with Wi-Fi? So let's understand, like phone sending a request and receiving data back, how it is happening. So like suppose that is a internet, the ISP, then you have a broadband. Yeah, this is your Wi-Fi router. Then you have a device which is connected to the Wi-Fi wireless over there. So this modem, like till your home, this Wi-Fi router connected to the one in the pole, your electric pole, something with connected to the GPON or over the fiber. Backend, this ISP also have a backbone till their hub or their data center. Okay, so once you request, suppose that you type google.com. So this request went to the your Wi-Fi router, then Wi-Fi router sent it to ISP sent it to Google server, then back to the ISP, then modem to your end devices. It use IP address, DNS, and connectivity, signal strength, coverage, everything that used to communicate end to end. Like it's a two-way communication, sending data and receiving data is a part of wireless that communicate with end-to-end devices. Though there is a Wi-Fi architecture where all the connectivities happen from the back end, that we will discuss in upcoming videos. After that, we will discuss about the frequency band and speed that in using in the Wi-Fi technology, like 2.4 gigahertz and 5 gigahertz. 2.4 gigahertz covers a wider range but is slower, but 5 gigahertz faster but shorter range. So if I talk about that definition between 2.4 gigahertz and 5 gigahertz, then if talking about the speed, that's slower than 150, approx 150 mbps, but in 5 gigahertz is still 1 gbps. Range longer, it penetrates the walls, but in 5G shorter, weaker through the walls. Interference more crowded with Bluetooth microwaves, more interference in 2.4, but in 5 gigahertz there is a less interference. Few devices use it because there is a multiple overlapping channel. Best channel is 1.6.11, 3 overlapping channel is 2.4 gigahertz have, but in 5 gigahertz we have 23 overlapping channels in 5 gigahertz. Then best for large home browsing, IoT devices, and 5 gigahertz gaming, streaming, video calls, and other critical services where it's need speed. So this is the overview difference between the 2.4 gigahertz and 5 gigahertz, which we use as a wireless as a frequency. After that, we will discuss about RSSI and SNR. So RSSI stands for received. This is a received signal strength indicator. Is in the negative value in dBm, and closer to the zero is good. RSSI indicate that what is the strength of your wireless signal or SSID less than -55 dBr is better. So like if you have your mobile, it's a wireless access point mounting in some areas. How much signal strength you are receiving with your Wi-Fi router is called RSSI, signal strength indicator. It's calculated in dBm. Okay, and that minus is better. Like we are always talk that -45 to -65 we consider as a good. After that, signal can be reduced or speed can be impacted. SNR stands for signal to noise ratio. Higher SNR is better. Above SNR about 20 is good. The Wi-Fi signal is affecting multiple obstacles, and SNR provide the detail how much noise or disturbance in your signal has. It means in your wireless network there are multiple other waves or infrared or other devices are also interference which will work using the same frequency like 2.4 or 5 gigahertz. So it will also create noise in your wireless network, so your signal, your coverage, your quality can be affected. If I'm talking about Wi-Fi ranges, that like indoor in indoor. So if I'm talking about the indoor, then it's a home. Wi-Fi signal typically travel 30 to 50 feet, 10 to 15 meter through walls and furniture. Outdoor, that Wi-Fi is rugged and high capacity with the external antennas, in which open space with no obstacle. 2.4 Wi-Fi can reach up to 150 feet and 5 gigahertz up to 75 feet. It's basically used in ground, open theater, school, colleges, parks, and public areas. For internet enterprise grade router, high powered router and mesh network can extend coverage even further up to 100 feet or further. So it used like mesh technology or with extended. So it can extend the signal to the further distance. So friend, these are the some Wi-Fi range which we have discussed. After that, we will discuss about factor affecting Wi-Fi range. So first of all, frequency band. What frequency band your router, your modem, your device is supporting, like it's operate 2.4 or 5 gigahertz. 2.4 band travels faster but slower, but 5 gigahertz faster but shorter range. Obstacle involves like concrete wall, metal, water, even can block your weaker signal strength. Power antennas, how powerful router with a better antenna you have, that can extend Wi-Fi range significantly. Interference, other devices like microwaves, cordless phones and neighboring Wi-Fi networks can cause interference. That is also the factor affecting the Wi-Fi range. So how to improve Wi-Fi range? Place your router in a central elevated location, means don't hide your router like in a under the wall or behind the pole. Don't do this. Always place your router in an open area where it can spread their signal more. Spread their signal strength more, then more device can be connected easily without any obstacle. Line of sight should be clear. Use 2.4 band for better range. If you have devices, if you can use 2.4, that is better to the better speed. Avoid placing the router near metal objects like microwaves, so like walls, glass walls, water, and microwaves. Also use 2.4 gigahertz frequency. So in your kitchen or some area where microwaves and other devices are there, then your Wi-Fi speed or range will be impact. So please avoid all these things near Wi-Fi network or Wi-Fi router. It can improve your Wi-Fi range, your coverage, your speed. So friend, that is a very small video on the how Wi-Fi works and what is the few parameters which we can improve our Wi-Fi range and what the things impact our Wi-Fi range. I hope you like this video. So please like, subscribe my channel and share this video with others, so you can immediately get the notification whenever I upload my next video. So till then, please watch my video and keep learning. Thank you. Goodbye.